to do is talk about the heart. I'll spend today's class and then maybe half of next class talking about the heart. And next class we're also going to dissect a pig heart. Now we're going to use a pig because that's the animal that humans most closely resemble. And so if you need a transplant, a heart, like a valve, you get it from the pig. It turns out humans are very, very similar to pigs. It's not a very nice thing to think about.
And sheep, right?
Right, they are sheep. They're lots of pigs. Now, what I would like to do, just to start, is to look at a heart, like this one right here. Just look at its external anatomy. Have y'all done this? Have you started reading yet? Yes. Okay, good. I'm going to point out a number of things. The pointed end of the heart here, the apex, the superior aspect from which the great vessels emerge, that's the base. Okay. Now, with respect to the great vessels, the anterior-most great vessel is the pulmonary trunk. The aorta arises behind it, and as it ascends, it forms a little arch. So we have the ascending aorta arising behind the pulmonary trunk. It forms an arch, and it dives back down behind the heart. This part is called the descending thoracic aorta. Yeah. So the aorta has three parts. It's got an ascending aorta, an aortic arch, and a descending thoracic aorta. All right. If I were simply to open up this heart here, I would notice that inside there are 4 chambers. Okay, there's one up here and one up here. The upper chambers are called atria. A-T-R-I-A. And then the lower chambers are called ventricles. When a person is facing you, okay, their right atrium and right ventricle are on your left side. Keep that in mind when we're identifying chambers. So, right atrium, right ventricle. These are the chambers on the left side. Left atrium, left ventricle. And then these structures here and here are valves. Their purpose is simply to control blood flow as it passes from the upper chambers into the lower chambers. So for instance, on the right side, this is called the tricuspid valve, and it's going to regulate blood flow from the right atrium into the right ventricle. At the same time, on the left side is a mitral valve. And it's going to regulate blood flow from the left atrium to the left ventricle. Okay.
Is there any significance with the tri?
Yeah, tri means it's got 3 cusps
Okay.
or flaps. Okay? Oh wait, it's on this side. So it's got 3 cusps or flaps, whereas the mitral valve used to be called the bicuspid valve because it had 2. Some textbooks still use that terminology, but in a hospital setting, no one will know what you're talking about if you say bicuspid valve. It's not used. The term mitral valve is used instead. And it's called a mitral valve, by the way, because it resembles a bishop's mitre. You know, that thing that goes up like that hat. I'll point out some fun facts. The coronary arteries, the arteries that provide blood flow to the muscle of the heart, the myocardium, they originate from the ascending aorta. So here's the ascending aorta. Look right here. This is the right coronary artery. Okay. Now, the pulmonary trunk's in the way here. Okay. But if it wasn't, we could see that this left coronary artery, it's called the left main, is originating from the left side of the ascending aorta. It's kind of moving behind the trunk and it's attaching like that. But as the left main comes down, it splits. And one of its branches is called the LAD, like LAD. It stands for left anterior descending coronary artery, and it reaches all the way down to the cardiac apex. The other branch, this one here, is called the left circumflex. And it's going to pass around the left ventricle toward the back of the heart. Okay. So just like the right coronary passes around the right ventricle to the back of the heart, the left circumflex does the same on the other side. Okay. When people say they have 3-vessel coronary artery disease, you hear that term a lot. I had an angiogram and they told me I had 3-vessel disease. They're talking about the right coronary artery, the LAD, and the circumflex. They're saying that all 3 of those vessels are diseased. When we say disease, we mean it has atherosclerosis, the buildup of plaque, which narrows the vessels. Is everybody following me? Is this kind of fun now? Okay. Now, you don't see it on this model, but there are grooves along the surface of the heart. Okay. Particularly between the atria and the ventricle. So between the right atrium here and the right ventricle, this is a little groove. We can either call it and another name for a groove, by the way, is sulcus. S-U-L-C-U-S. So we can call this groove that passes between the right atrium and the right ventricle the right AV sulcus, means atrioventricular sulcus. Or, because the right coronary artery flows within it, we could call it the right coronary sulcus. On the left side, between the left atrium and left ventricle, we have another sulcus. So we could call this one the left AV sulcus, or because the circumflex travels within it, we could call it the left coronary sulcus. Okay. Now, the anterior part of the heart here is formed largely by the wall of the right ventricle. Remember, right atrium, right ventricle. The apex of the heart, though, is formed from the left ventricle. It turns out there's a little groove that runs down between the right ventricle and left ventricle, and we call this the anterior interventricular sulcus. Inter means between. So it's the groove that runs between the ventricles, the anterior interventricular sulcus, and the LAD travels through it. Now, all of these sulci, all of these grooves are filled with fat. And so what you'll notice is that the coronary arteries, whether it's the right, the LAD, or the circumflex, they're surrounded by fat. And you'll see that on the pig heart. So anterior, these are just markings on the surface of the heart. Notice that there are veins, which are color-coded blue. Okay. By the way, veins, there's a difference between arteries and veins. Arteries carry blood away from the heart. Veins carry blood toward the heart. Okay, so coronary arteries carry blood from the aorta toward the heart. Coronary arteries are carrying oxygen to the heart muscle. Now, once that oxygen's been extracted by the heart muscle, the blood returns to the heart via veins. And so you see the veins color-coded blue because these veins are carrying unoxygenated blood. The veins are not called coronary veins. Instead, they're called cardiac veins. For instance, the one that accompanies, that travels right next to the LAD is called the great cardiac vein. Okay. I'm not going to test you on the names of veins. But for instance, on the back, this one here right in the middle of the posterior wall, this is called the middle cardiac vein. But all of these cardiac veins empty into this larger vessel here along the posterior wall of the heart called the coronary sinus. So the coronary sinus is draining cardiac veins, okay, draining unoxygenated blood that's already delivered blood flow with oxygen to the heart wall. And then the coronary vein is going to carry this unoxygenated blood to the right atrium. That's what we see happening here. By the way, the right atrium is color-coded blue because it's carrying unoxygenated blood. So is the pulmonary trunk. I want to point one more thing out before we start drawing some pictures and talking in more detail. The superior vena cava here is a large vein that's draining into the right atrium. Okay. It's carrying blood from the head, neck, and upper extremities. Okay. Blood that's already given up its oxygen, and now it's returning to the heart. And then down here, the inferior vena cava is also draining into the right atrium. But it's carrying blood from areas below the diaphragm. So superior vena cava above the diaphragm. It's carrying blood that's been drained from the head, neck, and upper extremities, all parts above the diaphragm. Whereas the inferior vena cava is returning blood that's coming from below the diaphragm, like the abdominal cavity and the pelvis and the lower extremities. All that blood's going to drain into the inferior vena cava before returning to the heart. Everybody follow this? Complicated stuff, huh? Yeah. So, if you listen closely, what I have told you is that there are 3 veins that empty into the right atrium. The right atrium receives blood from 3 different veins. What are those 3 veins? Well, no, it's the coronary sinus is considered kind of a modified vein. So the great cardiac vein drains into the coronary sinus. The coronary sinus then drains into the right atrium. But you have the right point. So one of those veins that drains into the right atrium is in fact around the coronary sinus. CNS. The second one here is the inferior vena cava. And the third vein that drains into the right atrium, superior vena cava. Now, that blood that collects within the right atrium is then going to pass, look what it's going to do, it's going to pass through this valve right here, the tricuspid valve, down into the right ventricle. Okay? That's the direction of blood flow. Then when the heart goes to contract, the right ventricle is going to pump that blood where? Into the pulmonary trunk. And the pulmonary trunk is going to carry the blood to the lungs where the blood can do what? It can pick up more oxygen because this is, up to this point, it's unoxygenated. It's already given up its oxygen. So blood flows to the right atrium, through the tricuspid valve, into the right ventricle, and the right ventricle pumps the blood up into the pulmonary trunk. Now, in order to pump it into the pulmonary trunk, that blood has to pass through a little valve at the base of the trunk. What do you think we call that valve? We can either call it the pulmonary or pulmonic valve because it sits at the base of the pulmonary trunk. Blood's going to pass into the pulmonary trunk. And notice that the pulmonary trunk bifurcates, it splits into a left pulmonary artery and a right pulmonary artery. Those guys, if you can quiet just a little. That's right. All right. So, and the reason that the pulmonary trunk bifurcates is that you're going to send blood both to the left lung and the right lung. So here's the pulmonary trunk, or you could call it the main pulmonary artery, coming up like this, and it's splitting or bifurcating into a left pulmonary artery and a right one. And these pulmonary arteries deliver blood to the lungs. In fact, what they do is they enter the lungs, they branch into smaller and smaller vessels. So the pulmonary arteries are going to branch into pulmonary arterioles, which ultimately branch into tiny vessels called pulmonary capillaries. And the pulmonary capillaries surround the air sacs of the lungs. This is where gas exchange occurs. So the pulmonary capillaries are going to pick up oxygen, and they're going to drain into vessels called veins. At first, tiny veins, we'll call them venules, but then into larger veins. And from each lung is going to emerge 2 pulmonary veins. Okay. For instance, on the left side, you can have 2 pulmonary veins now that are carrying oxygenated blood. They're right here. They're going to drain into the left atrium. And on the right side, you're going to have 2 pulmonary veins now carrying oxygenated blood from the lungs to the heart. They're going to drain into the left atrium. So, whereas the right atrium drains 3 different veins, superior vena cava, inferior vena cava, and coronary sinus, the left atrium drains 4 veins. The 2 right pulmonary veins and the 2 left pulmonary veins. These pulmonary veins are called pulmonary veins because they're coming from the lungs, and the term for lung is pulmonary, and they're delivering blood flow to the heart, so these vessels would be veins. You carry blood to the heart, then you're a vein. Look how big the left atrium looks from the posterior aspect. Okay. Now, after blood collects within the left atrium, it's going to pass through this valve here, between the atrium and the ventricle. That's called the mitral valve, to reach the left ventricle. Now, at the same time, the right ventricle is contracting, the left ventricle is also contracting. While the right ventricle is pushing blood up into the pulmonary trunk, the left ventricle is taking oxygenated blood and injecting it up into the ascending aorta. It's going to pass from there into the aortic arch and down into the descending thoracic aorta. All of these components of the aorta have branches so that the aorta can distribute oxygenated blood to all parts of the body. Remember, the ascending aorta, its branches are the coronary arteries. The aortic arch, these branches are going to deliver blood flow to the head, neck, and upper extremities. And as we turn around and come down the descending thoracic aorta, we're passing blood to other parts of the thorax. And then this is going to pass down through the diaphragm.